I will be showing you how to prove if a translation is an isometry or not. And here we have the math right here. Our first point is AB, and A is the x, and B is the y. Our next point is CD, C is the x, and D is the y. We use these lines and we make triangles out of them and I gave each side a label of D1 or D2, and then over here you can see the math that we have it together. So the or the x-axis, sorry, gets A plus D1, the y-axis gets B plus D2, the x-axis gets C plus D1, and the y-axis gets D plus D2. And then the initial distance that we find at first before they're translated, we use the distance AB, CD, and we create A minus C plus B minus D. And we get this because A minus C is the x-axis slide over, and B minus D is the y-axis slide down, as you can see right here. To get the final distance, we do A plus D1, B plus D2, C plus D1, and D plus D2. And then we put them into an equation together where we put the x-axes together and the y-axes together, so we get A plus D1 minus C plus D1 plus B plus D2 minus D plus D2. And then what we do is we distribute the subtraction to the next part of the equation, and then we do A plus D1 times C plus negative C plus negative D1, sorry. And the D1s get x'd out and we get A minus C, and then B plus D2 minus, or negative D plus negative D2, and the D2's x out and it's cut off here, but you get B minus D, and then you can put that into the equation over here, A minus C plus B minus D, and as you can see they are the same, so the distance is the same, and therefore it is an isometry.